Okay, this time we're going to introduce decimal to binary conversions, and we're going to use a different method, repeated division by 2. Not a method that I use often, but it's a math trick. We should take a look at it and see what's there. Quick explanation of why it works. Think about it a little bit. When you ever divide something by 2, and it might be that concept of even and odd numbers, but when you divide something by 2, you always get a remainder of 1 or a remainder of 0. That's awful convenient. Sounds familiar, right? Binary, it's always 0 or 1. So if I start with a decimal number and I want to convert it to a specific numbering system like binary, I divide it by 2 because that's the power of that, the weighted power of that system. Um, it's going to do a conversion for me. And it works for hexadecimal too. We'll cover that in the future. So let's take a look at some examples. Let's use an easy number first, a smaller number like 41. And all I'm going to do is keep on dividing 41 by 2. I'm going to use a little bit different nomenclature than you might be used to. I'm going to put the 2 out here and divide this. And I'm going to draw another little area down below here. So 2 goes into 42 20 times, and it had a remainder of 1. So I'm going to put the remainder out here. And actually the remainder is going to be interpreted as the answer until we're done. So we're going to keep on dividing until we finish this, till we get down to the end, and we'll see what the end is. So 2 goes into 20 10 times. It has a remainder of 0. Make sure you list the remainder each time. 2 goes into 10 5 times. There's no remainder there. I'm going to stop rating the 2 because it just takes a little bit more effort. 2 goes into 5 2 times with a remainder of 1. If I get something wrong, stop me. Maybe it's a little bit hard to do in a video, but try something to get me back on track. But 2 goes into 2 1 time with a remainder of 0. And 2 goes into 1 0 times. And that has a remainder of 1. When I get the 0 down here, that means I'm done. Okay, and this, the remainder is going to be my answer. Now, I don't usually write numbers in vertical fashion. And when I do go to put them in horizontal fashion, I know that I have to be really careful about where the least significant bit and where the most significant bit is. So let's try taking this answer and making this the least significant bit and this the most significant bit. And let's see if it comes out the way we want. So when I write that, I'm going to get this. Now, that's an answer, and it's in binary. Let's make sure it's right. Right, so we know this is the 1, 2, 4, 8, 16, 32, right? Because the weights and powers of 2 for those positions. So what? 32 plus 8 is 40, right? That equals 40 plus 1 equals 41, and that's the right answer. So the first division you get, the remainder from that first division is always the least significant bit. If you write it just like I do here, so I have that on the top, that means your top value of remainders is going to be least significant bit. These zeros, the remainders of 0, they're significant. You got to use those in your answer until you're done, and then you have to do this till you get the 0. So that looks pretty good. It looks pretty easy too. Let's try it again just to make sure that we have it all right. Because what we're really doing is establishing a procedure and understanding what that's there. So we didn't ask you to come up with the procedure. You might be able to think it through and see what's there. We're showing you how to do it. We're going to just ask you to work those procedures and get it. So how about 385? Much bigger number, right? 2 goes into that. Now this might tax your math skills a little bit, but We're assuming that you know that when you come into electronics. So what? 1, carry the 1, that's 9. And 2, 192, right? 2 times 192 is 384. That's my checking. Technicians do that all the time. We have a remainder of 1. 2 goes into 192. And you should start to see the patterns. This is an even number, so I already know the remainder is going to be 0, as long as I do my division correctly. So what? 9 would be 18, and 12 divided by 2 would be 6. And that's that remainder of 0 that we have. 2 goes into 96. That's an even number, so I know what the remainder is already. Figure that out how you want, what order you want to write them in. But 2 goes into 9 4 times, and 1 6. That's 8, right? That's an even number, so I already know after this division I'm going to get no remainder, or a remainder of 0. And that's 24. As the numbers get smaller, we can go faster, right? 2 goes into 24 12 times with a remainder of 0. 2 goes into 12 6 times with a remainder of 0. 2 goes into 6 3 times with a remainder of 0. Boy, we had a string of even numbers there. Make sure you remember to always write the remainder of 0. 2 goes into 3 1 time with a remainder of 1. And 2 goes into 1 0 times with a remainder of 1. This 0 down here means we're done. That was part of the procedure. We know that based on our experimentation on the previous example, this is the least significant bit. This is the most significant bit. So all I have to do now is write that horizontally without messing up. So how many zeros are there? 1, 2, 3, 4, 5, 6. And that's how many I want to write. 3, 4, 5, 6, 1, 1. And as a good technician, we don't just write that and say, let's get out of here, I'm done. We check it, right? So we go back here and we say, well, there should be 2 1s at the top and 1 1 here at the bottom position. And then we count the number of zeros in between here, and we go over here and make sure we do that. And we say, yippee, I got that right. Even a technician double, triple, quadruple check, because we always have to have right answers. So I might do this. This is the 1 weight, 2, 4, 8, 16, 32, 64, 128, and 256. Right? So 256 plus 128. Do it formally because they're bigger numbers. 4, carry the 1, we get an 8. And that's 384. And don't forget that last 1 that we have to add on there. And that's 385. And we've checked our answer many different ways until it's there. And that's how you use the repeated division by 2 method. As I said, that works well also for hexadecimal numbers. You're dividing by 16. I'm probably going to need a calculator to do that. So hope that was helpful. See you the next time.